Well, pre-calculus classes, good morning, good afternoon, or good evening. We'll actually go ahead and get started with the first day of section P6 with rational expressions. There are actually 3 parts to this section, so unlike P5, a little bit more to this one. But what we're going to focus on certainly is finding domains, simplifying, multiplying, and dividing in the first couple of parts, and then eventually we'll also talk about adding and subtracting. But to start out, a rational expression is a fraction in which both numerator and denominator are polynomials, which we'll talk a little bit more about that. And the domain is the set of real numbers for which the expression is defined. So an example of a polynomial, when we say a rational expression has both numerator and denominator as polynomials, well, 2x to the fourth minus 6x squared plus 3 is a polynomial, meaning you only have positive exponents. It's fine that you have a constant term. You just can't have any negative exponents, no radicals like b or c. So, for example A, the domain is all real numbers. Now, again, I think most of your Algebra 2 classes certainly were using interval notation, negative to positive infinity. Now, when you have a square root, well, we are not going to worry about imaginary numbers yet, so the domain of a square root has to be greater than or equal to 0. So, basically, if you want, think of it as this has to be greater than or equal to 0. So that means, if you want, you can even algebraically solve it. So x minus 5 is greater than or equal to 0. So x has to be greater than or equal to 5. Now, again, as an interval, starts at 5, goes to positive infinity. And again, we'll go ahead and specify that as your domain there. Now, for this one, if you want to, again, we can say greater than or equal to 0. Certainly square both sides. So 5 minus x is greater than or equal to 0. Here I'm going to actually add the x over. And when we do that, be careful here, and this is one of the reasons why I like solving this one this way. This actually says x is less than or equal to 5, so that domain actually goes to negative infinity and then ends at 5. Again, when it's greater than or equal to, less than or equal to, we do use brackets there because you cannot get to infinity or negative infinity. That's where we use the parentheses. All right, for example D, here, when you have a rational expression, now we have a polynomial in both numerator and denominator. Well, for the numerator, the domain is all real numbers. For your denominator, x cannot equal 4. And the reason, if x equals 4, you would have a 0 in the denominator. And we cannot divide by 0. So basically, what's going to end up happening here is the overall domain will start at negative infinity. It has a break at 4 because it cannot equal 4. We use a parenthesis. Then it starts back up, or the next interval, again, cannot equal 4, goes to positive infinity. All right, for example E, square root of x plus 3 over x plus 7. Well, for this one, we now actually have 2 issues. First, we do have a restriction. X cannot equal negative 7. And then for the numerator, again, certainly I'm not going to actually, show the entire solving of this, but x has to be greater than or equal to negative 3. Now, the nice thing about this one, this restriction is not within this domain, so our overall domain is just negative 3 to infinity. So Again, if you are actually writing these out, everything is able to be printed off online. Now, simplifying rational expressions. Here, before anything is simplified, you always need to factor numerator and denominator if possible. Then divide numerator and denominator by any common factors, which will actually show you what that means. And then we do also want to include what are the excluded values or the restrictions in your final answer. So, for example, 2 here, you actually can't factor the denominator x minus 3. For our numerator, because a is 1, we don't have to do the entire splitting the middle process. Here we can just, what multiplies to -6, what adds to -1. So our numerator here will be factored using -3, +2. So that ends up being x minus 3, x plus 2 over x minus 3. So there is the factoring. Now divide numerator and denominator by any common factor. Well, here the x minus 3's cancel out. So our end result is x plus 2, except x cannot equal 3. Even though we have canceled that out by reducing, you do still have to indicate what are the restrictions to that problem. For example, 3, again, we do have some factoring here. For the numerator, we can first factor out an x, leaving x squared minus 4. And then that is a difference of squares, x plus 2, x minus 2. Don't forget to carry the x over. That's one of the common things that we see. It's easy to forget about. All right, for the denominator, x squared plus x minus 2. Again, trinomial factoring here. What multiplies to -2 adds to 1. Well, that's going to be +2, -1. So that is x plus 2, x minus 1. Certainly I could have written that there, but since this one only has just one step, I did go ahead and put that over there. All right, now as far as what we can reduce, the x plus 2. That's going to leave x minus 2 over x minus 1. Nothing else cancels here. You cannot reduce this x with the x in the denominator. These two quantities obviously aren't the same. And then to finish our restrictions, x cannot equal -2 or +1. The order you list those out in is not an issue at all. So, for example 4, I'm going to actually do 2 different things here. I am going to not only rewrite this in standard form, I also think it's going to be easier if we factor a -1 out of the numerator. So that'll make the x squared positive, -x, -12. And so now for the numerator, we are looking at what multiplies to -12, adds to -1. Well, that's going to be, with the -1 there, x minus 4, x plus 3. Now, for the denominator, because a is 2, we are going to have to split the middle. 2 times 4, so we're looking for what multiplies to 8, adds to -9. Well, that's going to be -8 and -1. So what I'm going to do to make sure I have room, go ahead and start our factoring here and eventually write it in over there. So for this one, when we group, can take out a 2x, leaving x minus 4, take out -1, x minus 4. So for this, our factors are x minus 4 and 2x minus 1. Those both cancel. As far as our end result here, I'm going to go ahead and just write the negative. You don't necessarily need the entire -1. certainly not a problem if you do write it out with the full -1 over 2x minus 1. So as far as only other thing we do need, our restrictions, x cannot equal 4. And then for this one, well, think about if you set it equal to 0, add 1, divide by 2. X also cannot equal a half. All right, multiplying rational expressions. Now, one other thing, too, that I will mention, whenever you have these, do not feel like you need to go back and distribute the x through, the negative through. Leave things in factored form. It's much, more, it's much simpler if you do that. So, multiplying rational expressions. Again, always start out factoring first. Then divide by common factors, reduce, however you want to look at that. Then multiply the remaining factors. And again, we're going to leave things factored. And as always, we are going to also include the excluded values. So for this first one, x squared plus 2x over x minus 3 times x squared minus 2x minus 3. Well, for example 5, something we haven't really seen yet in this set of notes, this is where we are going to use a GCF, so we can factor the x out of x squared plus 2x. And then for this one, what multiplies to -3 adds to -2? Well, that's -3 and 1. So x minus 3, x plus 1 over x. Now, as far as what we can reduce, think of it as this is almost like one giant fraction right now. Anything that's anywhere in the numerator and anywhere in the denominator in common can be reduced or canceled. So we can get rid of the x minus 3's. We can also get rid of this x. And so our answer, x plus 2 and x plus 1. And again, our two restrictions, x cannot equal 3. And again, something we haven't seen yet. If you just have a single x term, well, again, if you were solving these, you set things equal to 0, so that would just mean x is 0. So those are your two restrictions there. All right, example 6 has a little bit more going on with it. First off, we are going to factor out that x. And here we do have trinomial factoring. What multiplies to -10 adds to -3. Well, that's going to be x minus 5 and x plus 2. Over here, what multiplies to -5 adds to -4. That's going to be x minus 5, x plus 1. And then here, we have a GCF. We can factor out a 2x. And then that leaves 2x minus 1. All right, only other thing that we do have to do over here is split the middle. Don't have a lot of space, so I'm going to just do that over here. What multiplies to 6 adds to -7. Well, that's going to be -6 and -1. So 2x squared minus 6x minus x plus 3, which then we can group, factor out the 2x, x minus 3, factor out the -1, x minus 3. So this gives us x minus 3, 2x minus 1. I guess here I can go ahead and finish that off over x minus 5, x plus 2, x minus 5, x plus 1. I know I'm kind of cramped for space here. So we can get rid of x minus 5. We can get rid of 2x minus 1. And then the other thing that we can also do is we can get rid of this x and that x. Now, the 2 obviously is still going to be in our end result. So our numerator in the end is x minus 3 and x plus 1. Our remaining denominator, I'm going to go ahead and put the 2 out front, and x plus 2. And then our restrictions start here. X cannot equal 5, negative 2. For the 2x can't equal 0. For the 2x minus 1 cannot equal 1/2. All right. Final thing, when you're dividing rational expressions, to find a quotient, meaning division, of two rational expressions, you invert the divisor and multiply. Now, when we say the divisor, that's the fraction that is being divided by. And so for this one, it's just x to the third minus 8, x squared minus 4. So we're going to flip or invert. And then do a bunch of factoring. I guess I don't need any parentheses anywhere yet. These are both going to be difference in sum of cubes. Now, the nice thing about each of these, they're essentially going to be the same factor pattern. Cube root of 8 is 2. So this is x minus 2. Square the first term. So there's your a and your b. So x squared. First sign's the same. The next one is the opposite. Then just multiply x and 2. 2x for the ab term in the middle. And then at the end, you square b, and it's always positive. X squared minus 4 for that denominator is a difference of squares, x minus 2, and x plus 2. The sum of cubes for x cubed plus 8, again, first parentheses has the same sign. Then everything else will match up kind of like this one. The only thing that's going to change is your sign there is opposite. And then as far as x squared plus 2x plus 4 goes, if you were already looking to try to factor it, well, it actually matches this. And so it actually won't factor. You will not find anything that multiplies to 4, adds to 2. These were strategically done this way, though, knowing that they would cancel. So x plus 2's cancel, x minus 2's cancel. The only thing that's left is, and again, I guess we don't really need the parenthesis, x squared minus 2x plus 4. Now, as far as our restrictions go, x cannot equal 2, x cannot equal negative 2, so I'm just going to say plus or minus 2. Now, the nice thing about this, these quadratic portions that come from a sum or difference of cubes cannot be factored. They actually would net imaginary solutions. We do not worry about imaginaries in setting our restrictions. So that's everything for day 1 from P6.